The fever in the Pacific at this exact moment, across a 6,000-mile strip of open ocean stretching from the Galapagos Islands to the international dateline, the largest body of water on Earth is running a dangerous, unnatural fever. If you were to look at it from the deck of a container ship cruising along the equator, you would see nothing out of the ordinary. Gentle turquoise swells rolling under a bright tropical sun. An endless blue horizon. No violent thunderstorms, no roaring winds, no dark squall lines tearing across the sky. That serenity is a complete lie. Underneath that flat, calm water, the temperature of the upper 300 meters of the Pacific Ocean has surged past critical thresholds. A colossal plume of superheated water, an oceanic Kelvin wave carrying millions of terajoules of pure thermal energy, has crashed into the South American coastline while pooled across the surface. Here's the part that should stop you. Most people treat an El Niño as an abstract seasonal forecast, something slow, distant, and mild that gently nudges winter temperatures 6 months down the line. We are taught to think of climate anomalies as gradual shifts that give human infrastructure plenty of time to adapt. That assumption will get people killed because when the equatorial Pacific Ocean crosses into a Super El Niño thermal state, the atmosphere resting above it does not wait 6 months to react. It does not wait weeks. It undergoes what fluid dynamicists call nonlinear atmospheric coupling. The planetary trade winds, the east to west, winds that have driven ocean currents and stabilized global weather patterns for centuries, have entirely stalled. The tropical Walker circulation, the colossal atmospheric lung of the Pacific Basin, has broken in half. And the instant the ocean and the sky lock gears, the global jet stream does not just bend, it ruptures. The atmosphere of planet Earth is a closed, pressurized thermodynamic loop. When you dump an unprecedented column of heat and rising moisture into the exact dead center of that loop, you are shoving a massive, immovable boulder into a river running at 200 miles an hour. The shock wave does not take months to arrive. Over the next 10 days, that atmospheric disruption is scheduled to slam into 4 continents simultaneously. The real question is not whether this El Niño is real. The satellites and deep sea Argo floats have already confirmed the numbers. The real question is what happens to the ground beneath your feet over the next 240 hours, and whether the global power grid, agricultural supply lines, and emergency services are remotely prepared for what is about to fall out of the sky. The broken machine, how the jet stream gets hijacked. To understand why the weather outside your window is about to change violently within the next 10 days, you first have to understand the machine that controls every storm system in the northern and southern hemispheres, the planetary jet stream. Under normal baseline conditions, the sun heats the equator, warm air rises, moves toward the poles, cools, and sinks. Earth's rotation spins that moving air, creating the high-altitude rivers of wind we call the polar and subtropical jet streams. In an average year, the trade winds relentlessly push warm surface water westward toward Indonesia and Australia. This creates the Western Pacific Warm Pool, a massive reservoir of hot ocean water that fuels towering thunderstorms over Southeast Asia, while cold, nutrient-rich water upwells along the coasts of Peru, Ecuador, and Chile. That balance is the baseline of modern human civilization. Our farming seasons, our reservoir levels, our shipping lanes, and our storm drain systems were all engineered around that specific distribution of heat. Now look at what a strong El Niño does to that engine. The warm water has sloshed back thousands of miles across the Pacific, pinning itself right against the Americas. The Western Pacific Warm Pool is gone. Instead, an area of ocean larger than the continental United States is boiling, at 3 to 5 degrees Celsius above historical averages. That vast stretch of hot water is pumping billions of tons of moisture straight up into the stratosphere every 24 hours. As that water vapor rises and condenses, it releases staggering amounts of latent heat. That latent heat acts like a massive thermal engine shoved directly into the path of the subtropical jet stream. Instead of meandering across the globe in predictable, undulating waves, the subtropical jet stream has been supercharged. It is roaring at over 230 miles per hour, extending in a straight, razor-sharp pipeline from the international dateline all the way to the coast of California and northern Mexico. When a jet stream moves that fast and carries that much thermal energy, it stops allowing weather to move naturally. It creates massive, stalled ridges of high pressure, what meteorologists call atmospheric blocking patterns, and pairs them with deep, violent, stationary low-pressure troughs. When weather systems stall, ordinary rain becomes an existential flood, and ordinary heat becomes a killing heat dome. The trap is loaded. Here is how it detonates over the next 10 days. Days 1 to 3. The immediate atmospheric river conveyor. The first phase of the disruption will hit the western rim of the Americas with surgical, mathematical precision. Beginning within the next 48 hours, the newly elongated Pacific jet stream will lock onto an infinite moisture source over the central tropics, forming a continuous atmospheric river, a roaring vapor corridor in the sky carrying more liquid water than 20 Mississippi rivers combined. The North American coastal assault that ye see osto misti storm track will drop far south of its normal seasonal position. Instead of dispersing rain across British Columbia and Washington state, the core of the vapor pipeline is pointed directly at central and southern California, continuing into the American Southwest. Precipitation, anomalies, automated weather models project rainfall rates exceeding 3 to 5 inches in 12-hour bursts along coastal mountain ranges. Orographic lifting. As this hyper-pressurized moisture plume slams into the Sierra Nevada and the transverse ranges of Southern California, it will be forced upward, cooling instantly and dumping biblical amounts of water and heavy, high-elevation snow. Mass wasting hazards. Burn scars from prior wildfire seasons will act as zero-friction slipways. Saturated topsoil will break free from bedrock, sending hyper-concentrated mud and debris flows directly into suburban drainage channels, slicing through major highway routes and rail corridors within hours. The South American coastal shock, Peru and Ecuador. Simultaneously, 4,000 miles to the south, the coasts of Peru and Ecuador will experience the immediate violence of localized convective collapse. Normally, the Peruvian coast is an hyper-arid desert, kept dry by the cold Peruvian current. Today, that cold current is buried under 5 meters of boiling equatorial water. Over the next 72 hours, extreme convective storms will trigger flash flooding across river valleys that see significant rainfall only once every 2 decades. Dry river canyons, quebradas, will turn into roaring mudflows within 30 minutes of cloudburst initiation, isolating coastal settlements and overwhelming regional infrastructure that was never built for water. Days 4 to 6. The Western Pacific asphyxiational. The eastern rim of the Pacific Basin drowns under atmospheric rivers. The western half of the planet will experience the brutal, suffocating mirror image of an El Niño setup. To have massive air rising in the east, physics demands that massive volumes of air must sink somewhere else. That descending arm of the fractured Walker circulation is parking itself directly over Indonesia, the Philippines, Papua New Guinea, and eastern Australia. The agricultural lockout. When high-pressure air is forced downward from the upper troposphere, it compresses and warms. This completely eradicates cloud formation. Across the vast agricultural belts of Southeast Asia, convective monsoonal showers will shut off instantly. Ground surface temperatures will spike 4 to 6 degrees Celsius above daily norms within 4 days. Topsoil moisture, critical for late-stage rice and palm oil production, will evaporate at rates exceeding 8 millimeters per day. This is not a slow drought that develops over 2 years. This is what atmospheric scientists call a flash drought, a sudden, violent collapse of soil moisture that occurs in less than a week, shocking crops during their most vulnerable growth stages. The Australian fire set up in eastern Australia, the sudden stalling of maritime easterly winds combined with sinking, superheated interior air will drag relative humidity levels down into single digits. Over days 4 to 6, forest-fueled dryness indices across Queensland and New South Wales will cross historic danger lines. Any dry lightning strikes along the fringes of the descending air mass will find tinderbox conditions. threatening an explosive and unseasonably early start to the regional wildfire season. Days 7 to 8, the downstream Atlantic and monsoonal fracture by day 7, the atmospheric shock wave will have fully propagated through the global upper tropospheric wave train, crossing the equator and detonating inside the Atlantic and Indian Ocean basins. This is where the El Niño stops being a Pacific phenomenon and reveals itself as a coordinated planetary scale disruption. The Atlantic shear wall across the tropical Atlantic and the Caribbean Sea, the upper level outflow from the Pacific El Niño, engine will accelerate eastward across Central America at speeds exceeding 80 knots. This creates massive vertical wind shear. Surface trade winds blow from the east at 15 knots, while the upper atmosphere roars from the west at 80 knots. Any tropical wave or embryonic storm attempting to organize in the Atlantic main development region will have its convective tops sheared off and blasted thousands of miles away before a low-pressure eye can form, while this creates a temporary ceiling on Atlantic hurricanes. It causes a severe secondary problem. It traps vast amounts of unreleased thermal energy inside the Caribbean Sea and the Gulf of Mexico. The heat cannot escape through tropical cyclones, turning those waters into a volatile, boiling energy battery waiting for the shear to fluctuate. The South Asian monsoon disruption in South Asia, the teleconnection will collide head-on with the regional monsoonal flow. The descending branch of the Walker cell will force a sharp break in the monsoon trough across central India. Agricultural valleys that rely on steady, distributed monsoon rains will experience sudden, baking 10-day dry intervals. The moisture that is blocked from moving across the plains will be driven north against the topographical barrier of the Himalayas. As that moisture piles up against the mountains, it will trigger catastrophic localized cloudburst events, dumping 8 to 12 inches of rain into steep Himalayan river canyons in fewer than 4 hours. The resulting flash floods and glacial lake outburst hazards, GLOFs, will pose an immediate critical threat to downstream hydroelectric dams, roads, and mountain populations. Days 9 to 10, the European omega block and polar fragmentation. During the final phase of this 10-day forecast window, the altered subtropical jet stream will interact with the polar jet stream over the North Atlantic, establishing a classic high-amplitude omega block across Europe. The architecture of an omega block and omega block gets its name from the Greek letter omega doulos. The jet stream contorts into a massive northward bulging ridge flanked on either side by deep, stationary low-pressure cutoff troughs. Once this pattern locks in place, weather over Europe will grind to an absolute halt. Under the central ridge, a massive dome of high pressure will trap heat over Western and Central Europe. Temperatures will soar 8 to 10 degrees Celsius above seasonal norms. Urban heat islands will bake. Air quality will deteriorate as particulate matter becomes trapped near the ground, and regional energy grids will face severe strain from air conditioning demand. On the flanks of the block, the cutoff lows pinned on the western and eastern edges of the ridge will remain completely stationary over the Mediterranean and Eastern Europe. These systems will pull endless moisture from an exceptionally warm Mediterranean Sea, dumping days of continuous torrential rainfall onto saturated river basins and triggering severe regional flood alerts. The CTA, Crust and Storm. If you're starting to understand that what happens in the middle of the Pacific Ocean is not an isolated story, but the master switch that controls the air you breathe and the weather over your home, that is why we built this channel. Here at Crust and Storm, we do not give you cheerful weekend forecasts or surface-level news clips. We track the real, raw, uncompromising physical machinery of our planet, from the depths of subduction zones to the high-altitude dynamics of the stratosphere. Take 2 seconds right now to hit the subscribe button. It costs you nothing, but it guarantees that when the planet's climate engines shift, you have the facts before the disaster arrives. The cost of a shifting planet. Why should the average person care about a 4-degree anomaly in the Pacific Ocean? Because human civilization has built its entire global infrastructure on the dangerous assumption of climatic stationarity. We built our cities, our highway bridges, our port facilities, and our electrical networks based on the historical weather patterns of the 20th century. We assumed that rivers would only rise so high. We assumed that the jet stream would always stay within certain boundaries. We assumed that dry seasons would arrive on a predictable schedule. The energy moving through the atmosphere over the next 10 days is not new energy created out of thin air. It is stored planetary heat that has been building within the ocean, now suddenly escaping into the sky all at once. The atmosphere is attempting to rebalance itself. And when a system the size of planet Earth attempts to balance billions of terajoules of excess heat in 10 days, the transition is never smooth. It happens through landslides tearing down mountain passes. It happens through atmospheric rivers, overwhelming urban spillways. It happens through flash droughts, drying out agricultural basins in a week. The supercomputer weather models have run their simulations. The oceanic buoys have registered the heat. The atmospheric jet stream has already locked onto its path. Over the next 240 hours, the map of global weather is being redrawn in real time. The machine has started. The only question left is whether you are paying attention.